Right, I want to start by doing a little bit more on forces. So you might need to pause and take notes a little bit. So resistance. This is present whenever a solid object moves through a liquid or gas, and it always acts in the opposite direction to motion. So the thing we've spoken about is air resistance. And you need to get used to drawing these force diagrams. So as an example, I've got a parachute and a basket. And if you consider the forces acting on the parachute as it falls downwards as a whole, we've got the weight coming down, and then there's a resistive force acting upwards. So that's due to air resistance. Obviously for a parachute it's quite a bit of air resistance. Just splitting it apart, because you can also think about, well, what forces are acting on the actual parachute itself. So that bit of fabric, if you like. So we've got the resistance coming up. And then if you think about if you were that bit of cloth, what those strings are doing, they'd be pulling down on you. So this is tension in the strings. So remember we spoke about tension being a pulling force. So they're pulling down because of the weight of the basket underneath. And then there's also the weight of the actual fabric itself that's acting downwards. And then thinking about the forces that are acting on the basket as it falls down. So we've got these strings coming up, and they'll be pulling on the basket. So we've got tension pulling upwards. And then we've got the weight of the basket acting down, and we'll also have some resistance to motion, some air resistance as well, acting on the basket itself. So you will need to have to kind of separate out different things, and if you just think about, okay, if I was the basket, what's happening? If I'm that bit of cloth, what's happening? Or you can take the system as a whole. I don't think we need to do too much on this one, but the other force to think about is friction, which I think is a bit more obvious. So this is a force which prevents two surfaces from sliding. And that will also oppose motion. So I was just looking around trying to think of what to use. If I just push this box along here, then acting parallel to the board, I'm going to have a pushing force for my finger, but there's also be some friction acting back that way because it's not a completely smooth surface. So there's a friction force acting backwards. And then smooth surfaces have no friction. So there'd be no force opposing motion between the contact of the two surfaces if it's smooth. Right, Newton's laws, we're not going to do them in order because we never seem to for some reason. So Newton's laws, you've probably heard of them before, but there's 3 laws of motion. And the first one we're going to look at is that when one object exerts a force on another, there is always a reaction of the same kind which is equal and opposite in direction. So if I push down, there's a reaction force that's pushing up from the board onto my finger that's equal to the force that I'm pushing down with. And if I push down harder, that reaction force will increase by the same magnitude. So if we think about having a table, in direction, I was going to put something else on there to the action force. Sorry. Right, so if we've got a book on a table and we're just looking at the forces acting on the book, then there's the book's weight acting downwards, and there's a reaction force of the same kind which is equal and opposite in direction. So this reaction force will equal the weight. That's quite a nice simple example. So this is the forces on the book. If we zoom out of that bit and think about the forces on the table, so I can put the book on the table over here somewhere. Then acting on the table, we've got a reaction force equal and opposite to this one, because this is the table acting on the book. So the book also acts down on the table. So we've got this force here that's acting down onto the table. And then we've got the weight of the table. Remember, this reaction force is the same as the weight of the book. So it's all kind of balancing out. And then the table's resting on the floor, so it's not totally parallel. And so here, where the weight of the table is acting down on the floor, there's going to be reaction forces acting upwards. And they're quite probably of different magnitudes, all these reaction forces. So we can put subscripts on them. So that's the forces acting on the table, and that's the forces acting on the book. One more example. Don't know if you need this or not actually, but I do. So we've got a light bulb hanging from the ceiling, and we can think about the forces acting on the light bulb. So there's the weight of the bulb acting down, and then this cord will be pulling up on the bulb, and that's your tension there. So if you could start, please, by doing page 158 in your online textbooks, and it's exercise 10A, question 1 to question 5, which is drawing some force diagrams. Please just ask each other if you need to.